All right, I'm Alan Berndt. We're going to talk about Perl and SDL development of games today. We're going to made a little breakout clone, so we'll go over how we implement that with Perl and SDL. A little introduction to SDL. It's a simple direct media layer. It's a library for doing cross-platform game development, such as drawing graphics to the screen and sounds, handling input, that kind of things. SDL Perl are the Perl bindings to this, which kind of gives you a little better, more familiar if you're a Perl developer interface to it. SDL is written in C, so nobody wants to write C. And then SDLX is a namespace in the SDL Perl library that gives you kind of higher level concepts such as game loops and stuff to make your life even easier. Installation is fairly easy. On Windows, if you have Strawberry Perl, which is recommended for Windows development, if that's your jam, you can just cpan m install SDL, and that'll give you all the binaries that you need for libSDL and all that goodness. OS X, I actually could not get it to work, so that was a kind of a hiccup there. I think it was something to do with the 32-bit libraries that it wanted to compile versus the 64-bit that I had. And then on Linux, everything's easy, right? So just cpan install it, and then you're good to go. So the first thing we're going to talk about here is the game loop, which is kind of, if you're familiar with game development at all, this is kind of the starting structure for a game where you want to kind of loop over, just repeatedly call this loop and handle all of the things that happen during a game. So we have here, I don't know how much you guys can read this, hopefully. This is just some little boilerplate to set it up, get some attributes for your game, the width and the height, title for the window. This DT sets kind of how often the frames happen, so you can, if you want your game to run faster or slower, you can just change this, and that makes it kind of easy to get balancing stuff sorted out. This exit on quit thing we'll talk about a little bit later. And then these are the kind of the handlers that you're going to set up. It works by these callbacks called handlers. SDL does. So the three main things that you want to handle are events, which is the keyboard input, joystick input if you're doing joysticks, those kinds of things. The move handler is what updates your game state. A lot of times it's called the update step. So that's just going to go through and change everything. And then the show handler is rendering to the screen, also called rendering sometimes. So these are kind of your three basic things. This is other than the elided stuff here. This is the whole program that we're going to dissect today. I don't know how easily I can make it bigger. We can try without.
It's a little hard to read the camera.
Yeah.
If it's that small.
Gotcha. But probably gonna have to resize them all as we go. But we'll deal with it.
The frame rate, the DT there.
Mm-hmm.
Can you select like a variable frame rate over a fixed frame rate, or?
Yeah, you can change it over the course of the running, and so kind of you see in this last command here, we're calling run on the app. So that goes through the loop, and every time the loop starts, it checks that DT. So if you change it within the loop, yeah, I think it's supposed to stand for delta time. It's I don't remember exactly how it works out. Might be the number of SDL ticks that happen.
That's the last update.
Yeah, between the calls to the move handler, if I remember correctly. I actually I didn't know how to do SDL and Perl before 2 weeks ago, so. I use it in C a lot more than I do in Perl, even though I told you nobody likes to write C. It doesn't have these niceties, so it was kind of nice to do it in Perl for once. But it controls how often the move handler gets called, essentially. So if you change that value, the higher it is, the less frequently the move handler gets called. So you can slow your game down or speed it up with that. And you can do that dynamically if you wanted to, say like you had something in your game that made the game go slower, like a slow motion thing. You could easily just change the DT and not have to worry about the rest of the, changing all the variables of things that are moving. So it gives you an easy way to change the timing. So we'll talk about the handlers one at a time here. The event handler, like I said, handles input devices and also handles events from your window manager, like losing focus, things like that, or if the window gets resized. Well, we're not going to go into any of that because I didn't have time to. So that can be a mystery you guys look up for yourself in the documentation. So here's kind of the simple game loop. Here we can make it bigger again. Can we see that now? So this is just going to handle these three events. The key down and key up events are pretty self-explanatory. And we're kind of passing the buck to this game object, which we saw back here. We have a breakout game class that we made that handles all of the game logic, just to kind of encapsulate it. So we're just going to pass these key events down. So the event has a few parameters. One of them for a keyboard event is this key symbol, which tells you what key was pressed or released. This quit event is when the window manager essentially is telling your app it's time to quit, or the OS. You know, if you shut down your computer, or you click the little X in Windows, or however you do it on OS X, it sends that SDL quit event. So you handle that, and it just calls app stop, which stops that run loop that we were running and quits your game. So it gets two parameters here, the event and the app. And the event is, as you can see, has information about what event was fired in this loop. And the app is just that same app from here that we were setting up to do all the controller stuff. It's actually a SDLX controller class, but the SDLX app is a subclass of that has some other stuff that you work on. So, you look a little confused there, Eric. You got a question?
No.
All right. Just
I'm sure it'll iron itself out.
yeah, just yell at me if you have a question. So, because size this one up again. So the next one we had the event handler and then the move handler. This one we offloaded absolutely everything to this game object. So we'll get into that. This is actually a little bit outdated. I should have updated this. So originally what it was doing is the game update would return a Boolean that said if we should quit or not, like if you ran out of lives. And so when it returned false, we will just call the app stop. That's the way I do a lot of update loops, but I didn't actually end up using that for this one. So that's a little outdated there. The step, that first parameter, is how much time has passed, which is actually, it should always be the DT, but if for whatever reason the computer that's running your game can't handle the DT, the delta time, it'll either be smaller if not enough time has passed, or I guess that's if the CPU is running too fast for some reason. Obviously it's not going to be exactly on the 1/10 of a second every time, or 1/1,000,000th of a second, or however fast you wanted it to be. So this step gives you how much actual time has passed, and it's usually 1 because it's the amount of DT that happened. It's relative to that. Again, the second parameter is the app, and then this T is the total time elapsed since you started the run loop, which I didn't find a use for in our breakout clone here, but I guess maybe sometimes you would want to know that. And then finally, we got the show handler. So this is for rendering the screen. And we get, again, two parameters. Delta is how much time since the last frame, which you could use for motion blurring if you're into that kind of thing. And then the app, again. So here what we're doing simply is we're going to black out the screen, because if you don't do that, then when you try and draw the ball, it'll have a little motion trail and never erase itself. So you want to black out the screen every time. Then again, we're offloading things onto this game object to actually draw all the game elements. And then you want to call this app update, which actually invalidates the screen. You can give it a rectangle if you had to do some optimizations. Say you only wanted to update the top left corner of the screen. You could tell it to just update that part. But for breakout, it was not very taxing on the computer, so we just let it update the whole screen every time. All right, talk about the game state and the objects that we have. So breakout's a pretty simple game. I'm sure you guys have all played it. So you have your lives and your score, and then the game objects that we're going to implement here. We got the paddle. I don't know how much you can see that. We'll make this one extra big. So we got the paddle, the ball, and the blocks. In case you haven't played breakout, which I doubt, you control a paddle at the bottom of the screen, bounce balls up at blocks, and try and break them. It's fun. So, talk about the objects. The paddle, this is what you control at the bottom of the screen. So these are the attributes that we'll have for it. Let me make it a little bigger for you guys. So it has an X position, just controls where it is. The velocity, which is actually kind of misleading here. There's some design changes after these parameters were set. So the Vx is actually the direction that it's traveling. So when you're pressing left, the Vx would be -1. When you're pressing right, the Vx would be 1. And it's either 1, 0, or -1. That one doesn't, so it's not really representative of the velocity, but that's what it was called. The width of the paddle, pretty self-explanatory, and the speed at which the paddle moves, which is really its maximum speed if you're moving left or right. Initially, I wanted to have like power-ups that drop from the blocks, but it turns out I don't have as much free time as I thought. So there's no power-ups, and the speed didn't really need to be a variable, nor the width. But what can you do? The blocks. The blocks are certainly the simplest element of this game. They don't move. They don't do anything fancy. They have a rectangle that represents where they are on the screen. This uses this SDLX rect class, which is just a simple representation of a rectangle. It has a x, a y, and a width and a height. You can ask it for its top and bottom, all that fancy stuff. Then it has a flag for if the block has been hit. And that's the reason that we don't just handle that inline is we want to kind of keep everything encapsulated. So the blocks in the collision detection can be set to hit, and then later on we'll deal with actually removing the ones that are hit. We'll get into that when we talk about the individual update handlers and stuff. And then lastly, they have a value. So in the original breakout, each row was worth a different number of points. So this just tracks how much those blocks are worth. And the different rows were different colors, so it also happens to track the color. And then the star of the game, the ball. So it has the X and Y position, the direction it's traveling. So this one uses some trigonometry, because I wanted to have a math refresher for you guys. Trigonometry here is instead of using like a Vx and Vy, which would have been a lot simpler, and I don't know why I didn't do it that way, and I thought about changing it, but again, the free time. So it has a direction and speed, which control where it's heading and how fast, and then a radius, which was maybe I thought I was going to have power-ups that made the ball bigger or smaller. That's a crazy idea. I don't know why I made that a variable. It's absolutely insane. So here we go. We'll handle some keyboard events. Can you guys see that now? So I don't have arrows on my keyboard that I use. So we're going to use A and D here for left and right. As you can see, it gets just these are the events that we saw a few, going ahead, not back. So here in this handler, we're calling this key press and key release. So we're going to look at how those are implemented now. So here we have key press. So all we're going to do is when we get an A, set the velocity of the paddle. That's this move object or move function just sets the Vx that we talked about to either -1 or 1, depending on your moving left and right. The space bar, this is something that I added later, launches the ball. So the game doesn't just start off with the ball going off and you're like, whoa, scrambling to control it. It lets you carry the ball with the paddle for a little bit, and then you can launch it when you're ready to play. And then the key release events just are reversed for the A and D. So that the reason that it does that instead of setting it absolutely to either -1 or 1 when you press the key is so that if you happen to say you're moving left and realize you got to move right, you want to be able to start pressing right before you let go of left. And these are the way that this is set up. It lets you do that so that the paddle doesn't just stop when you let go of left, and then the player's getting frustrated. You got to kind of pay attention to these minutia, otherwise people won't want to play your game.
Do you get those constants for free? Or do you use those somewhere else?
Oh, all the SDLKA, and those all come from the SDL, the use SDL. They're defined in SDL event, I think. So, because they're for the event handling, and the documentation is pretty good about telling you those, but they're also fairly self-explanatory, at least for the letter keys. Well, yeah, the SDLK, it's saying it's a key symbol. And like I said, I use this a lot more not in Perl than I do in Perl. So, but these are the same. So I already knew those ones and didn't think too much about it. So thank you for asking. Go over some other events. We don't need to zoom this one in because it's boring. So SDL active event is that's the window manager events. Like if your game loses focus or something and you want to pause, or if you want to handle resizes, that's a different event that I didn't even put in here. But this just lets you handle, kind of things that might happen if someone's talking on AIM or whatever the kids use these days, and if something pops up, you don't want their game to go off and they're typing A and D to their friends and losing that breakout. They're going to get frustrated and give you a bad review. And then the SDL quit again. You just want to stop when you get that one. And so this kind of handling of SDL quit is so common that you can just do this exit on quit thing. I think we saw that at the very beginning. Yeah, exit on quit, and then you don't have to bother handling with that. It'll just know if it sees an SDL quit event to just stop the game and move on. And I don't know how to work my little thing. Yeah, so now we'll get into the meat of the actual game here. So these are the move handlers, or the update handlers, as I usually call them. We're going to go over them one at a time here. So the paddle move handler, this is what you need to let the person actually move the paddle around. We set the velocity and everything, but that's not going to matter because we need to actually update it. So this gets called every 100th of a second or something, or every 10th of a second with that DT setting. And we get the paddle object itself, the step, which was that fraction of DT that was used, and then the app. And we're just going to change the X based on its speed and its VX. So this is rudimentary physics here, moving by the velocity and the how much time it's been. And then here we're checking to make sure you don't move off the screen, because that's very frustrating. You could deal with it, move back, but we're not gonna want that. The only kind of weirdness here is where the X of the paddle is actually the center of it, whereas normally the X would be, for the rectangle that's drawn, would be the left, but we're dealing with the center, so it just makes it a little easier for the calculations later on. So that's a pretty simple one. Now we got to do some planning for the ball handler, though, because this is where it gets fun. So we got kind of some situations we have to deal with here, because we're using physical modeling of these objects, pretending it's an actual ball bouncing around. And we do have discrete time steps. So you don't want to get into a situation here where the time step puts the ball here, and if you check just at the beginning and the end of each time step, you'd see the ball's here. Well, it's not touching anything, so it can keep on moving the way it's going. Then the ball goes off the screen and nobody likes your game. You get the second case, so you check for a collision, you see that it happened, and then you bounce it, you just reflect it down and think everything's great. It's not great, though, because look, you went and hit a second thing and you didn't update that. So now your ball's bouncing off the screen in a different direction. Still nobody likes your game. So what we're going to do is recursively check for collisions and then update the ball to this amount of time. So say, this is time 0, and we'll call this time 1. We're going to update it to that and then rerun the move handler with this reduced time step left. It's going to find that second collision, and then we'll bounce right back toward the paddle, and everyone will think it's great. You get millions of dollars like Notch. Something like that. All right, go through the code for this one. Not going to go through all of it because some of it's kind of boring, but the meat of it here. So we've got, this is the update handler for the ball, and if you guys have questions about this, feel free to stop me because this is a little bit hairy. The first thing we're going to do is we add these wall objects because for some reason the game didn't track those originally. So the ball handler creates them, and these are just the frame of the game field. So we got, this is looks like the left wall and the right wall and the top wall. We don't have a bottom wall, of course, because that's where the ball goes and messes you up. Lose your lives and lose at the game, and lose all your friends. So after we get these walls set up, we're going to run through this as long as we have some step left. And if you remember from this diagram, we're breaking this update into the little chunks of how much is not hitting anything. So we started out with probably about 1 in the step. And we're going to keep doing this repeatedly updating the ball position until we don't have any time left for this update, essentially. Here's everyone's favorite, some trigonometry. to update the X and Y position of the ball. And it's not really that exciting, just some cosines and sines. And then what we're going to do that's actually fun and not trig is find the best collision, we'll call it, which is just the first collision that's happening. So we're going to go through all of the game objects, which are the paddle, the ball, and these walls that we set up. Or the paddle, the blocks, sorry, and these walls. And we're going to find when the ball will collide with this. This collide routine sends or returns a hash of some information about a collision that might or might not happen. And we're going to figure out when we have the best collision, which I feel like that should maybe be a less sign, so maybe my game is broken, but who knows? It's just, so this best t that comes back from the collide is the amount of time before the ball hits that object. So if we're going to hit several objects in this time step, we want to find the one that's going to hit soonest, because we don't care about the second ones. It's going to bounce away and not hit those. And then we're just going to basically, pretty simple for loop to find the best collision here.
Well, wouldn't it be greater than because your best collision is really your last?
No, your first collision should be the best one because that's the one you have to deal with. Like if it's going to hit 2 blocks, here, if we go back to this, it's going to hit this wall and this wall up here on this first pass.
Oh, okay.
So we care about this one, which has the smallest amount of time until it gets hit. So I don't know if I ever fixed that. Maybe maybe this is all way overboard, and I could have just done one bounce and been fine with it. But who knows? Premature optimization, I guess. So if we did find a collision, if best is defined, that means we found some collision. So we're going to handle that by only updating to the fraction of time before that first collision. Then we're going to handle collision. This best O is just the object with which it collided. So that lets us, like, if we're going to bounce off the paddle or if we're going to set one of the blocks to hit, lets us handle those things. Well, it's not the bouncing at all. This is basically just tells the blocks if they got hit. And then here, we got some poor design, but again, lack of free time. So if the thing that we hit happened to be a paddle, we do this crazy bounce math, which just lets us, more or less what it does is let you, if you hit the ball with the left side of the paddle, it'll bounce to the left. And if you hit the ball with the right side of the paddle, it'll bounce to the right. If you just have it actually physically bounce off the paddle, the game's really boring because you don't have any say in where it goes. So that's what this crazy more trig is. And then this is the handler for bouncing off the walls and the blocks. Much less exciting because it just physically bounces off. The only cool thing here is if this best D gets set to either H or V, if it's a horizontal or vertical bounce, we don't have to deal with too many crazy angles because everything is a straight 90-degree line. So it reflects either vertically or horizontally off those things. And that's real math that works. I drew it on paper and made sure, that's the programmer way of doing their math. And then lastly, we're going to remove whatever chunk of time we spent doing this update from the step. And that'll let us go back to this beginning of this while loop and figure out what is left so that we can continue bouncing and have this sweet double bounce in one step.
So in theory, if the DT was set large enough, we would never actually see the 2 bounces. It would just appear here and then all of a sudden.
Yes, exactly. Yeah, and if we have time, we can probably play with the DT and see it bounce crazy. I won't ever hit the ball because I won't be able to control the paddle, but because when you increase it, when the ball's moving quickly, which would actually be decreasing the DT, it's inverse. So when the ball's moving quickly, everything moves quickly, and that's when you get those instances where it might hit 2 things in one update sequence because it's moving so fast that it could even pass through an entire block in one. This is something you run into like if you were making say like a first-person shooter, even with a normal delta time, bullets move very quickly, and you want to make sure that you're accounting for the continuous path rather than, you don't want to just say, oh, well, the bullet was here, and then the next second it's, 4 meters away. There's a lot of stuff you could have hit in that 4 meters. But for Breakout, it's probably not such a big deal, but, we want to talk about game development in general, not just how easy it is to make Breakout. Then we have this last case. This is where if there was no collision, we're just going to update the x and y by what we originally figured and set step to 0 because there's nothing left to do. And that should wrap up the ball. So we'll talk about drawing some stuff now. So this is the primitive drawing, and as you can see, it looks pretty primitive. So SDL gives you a lot of these graphics primitives that you can draw: rectangles, circles, things of that nature, lines. When I was first debugging the bouncing, because I drew it on the paper, but it didn't work quite right, I would have a little line showing which way the ball was going, and that helped a lot. Very useful for debugging your game development. You can draw lines everywhere and make it look like whatever you want. But obviously the game doesn't look that cool with the primitives. Or maybe it does. Depends on your aesthetics, I suppose. Yeah, so...
People pay extra for that these days.
yeah.
They do.
Well, it's easy to toggle between them, so, if you want to steal this game and try and make money with it off GitHub, go for it. So here we'll just go through these simple draws that make that picture from the last frame. These are all pretty well documented for SDL, so we don't need to spend too much time on them. But for the ball, we draw a circle filled. If you leave off the filled, it'll just draw the outline of a circle, which is another fun way to have a ball, but I liked it filled. You give it just the center as an SDLX point or an array of 2 variables, and then the radius of the circle and the color. And these colors are in RGBA format, so this is the first 2 are the red, the green, the blue, and then the alpha. I didn't really see the alpha working, but I might not have ever configured alpha for the video surface that it was drawing to, and that's way beyond what we have time to talk about, so we're going to pretend that you just always put FF as the last ones, and then it draws the color you wanted. The paddle is a filled rectangle. There is no real notion of an unfilled rectangle, so that one's just called draw rect. It takes an SDLX rectangle, or SDLX rect, which the paddle already had a function that returned its rect, so we just use that. And then the blocks, again, have their own rect, but we pick the colors based on their value here, and there was an array of colors that I should have included, but I didn't. But as you can see, it sets them, to fun colors all the way up. But then, if you don't want to make a game from the 70s, you can use sprites. Then you get this really cool, fancy-looking game. Sprites are, if you don't do game development, sprites are basically just pictures that you draw onto the screen. Mario was a sprite. Link was a sprite. They're all sprites. So we got sprites for the balls, for your lives, for the blocks, for your ball, and for your paddle. And I stole this artwork because I can't draw. So this is what I drew. Stole this artwork from a really cool game development site called Open Game Art that people just put all kinds of cool stuff you can use. Sometimes you have to give them credit, sometimes you don't, but it's good for when you're prototyping games especially. You can just go on there and find some stuff that looks reasonably like what you want. Then when you are confident you're going to make notch money, you can pay an artist to actually draw your stuff. So drawing with sprites. You need to load these sprites in, obviously, before you get them. So here's kind of the new function for creating a ball. This is just some fun stuff that we glossed over, sets up the position of the ball, but then here's the magic with just calling SDLX sprite new, and you give it the name of a file. I tried to use different formats than bitmaps, but it wasn't working well, and the free time thing happened, so we stuck with bitmaps, which are actually built into SDL by default. There are extensions to SDL that let you do additional image formats like JPEGs and PNGs and stuff, but I think I didn't have those configured correctly. So bitmaps are always there as a fallback. And then the draw routine, instead of drawing that filled circle, we're just going to set the sprites X and Y to the top left corner of the ball, because now when we were drawing a circle, we had it centered, but the sprite's actually a rectangle. It's a square in this case, but the image, images aren't circles, not bitmaps anyway. So we got to set the top left corner of the sprite and then just draw it to the application. Very simple. Not sure why they made you set these X and Y instead of just letting you pass where to draw it to the draw method, but I didn't write SDL Perl, so just had to deal with what they gave me. All right, sound effects. So games are boring if they don't make sound. So we had to add some sound effects to our game. This is kind of a last minute thing, so there's not too much detail on it. There is an SDLX sound package, but it didn't work at all for me. So I decided I would just write my own using these base SDL routines. So this kind of gives you an example of the difference between using SDL plain versus the SDLX thing. And the SDLX thing was much nicer for setting up the application and stuff, and I would have loved to use SDLX sound, except that it didn't work. If I played a sound, it just kept playing it, looping it indefinitely, and that was really obnoxious when you hit that first brick. Sounded like you were doing great at the game, but you weren't. So, there's a lot of boilerplate here. When we call new, we're going to open this audio, and you might think, oh, you don't want to do that on every new, but SDL is actually smart enough to know that for every open audio call you make, it'll wait till you close that many audios. But it turns out we're just going to quit the app and not worry about freeing up any resources because this is Perl, and we don't have to worry about memory management and that kind of nonsense. Then we have just some routines to play a sound and then load one up. This, you just give it a file name and it stores it so that we're not loading it. Every time you hit a brick, you don't want to have to load the sample again because it does take some small amount of time. So we just save it in a hash, and then when we call play, we either load the sample, or if we already have it, we don't worry about it. Just play that sample with the play channel method here. This -1 in play channel tells it to use whatever channel's available. If you have, if you only have 2 channels for playing sounds, you can only play 2 sound effects at a time. And we set it up here. This is where we pick 2 channels. But we don't want to actually manage which channels are playing sound and all that. So we just tell SDL to find an available channel and play the sound on it. If there weren't any available, it would just fail. But I don't know what you would do in this game to make that many sound effects happen. So 2 is sufficient, and we don't have to worry about it too much. And then, of course, we need music for our game. And there was an SDLX music class, and it seemed really great, but it didn't work if you were using the raw mixer calls. It would conflict with it and be bad times. So we added this very simple music method, which you tell it the name of a file, and it just starts playing that file over and over. To make it fancy, though, we're going to use this fade-in music, which you you give it a music chunk, which you get from this load muzz. I think SDL by default, we're using SDL Mixer here, which was one of those extensions, like the one that lets you load different image types. This lets you load OGs, FLACs, MP3s, pretty much anything you can think of. If you don't use SDL Mixer, it's a lot more of a pain to do anything with sound because you have to load them into the format that the sound card wants, and it doesn't help you at all. So SDL Mixer is where it's at for sound stuff. I wouldn't recommend trying to get by without it. Unlike SDL Image, which you can do bitmaps without, but definitely go with the Mixer. Gives you all this nice stuff. So we call this fade-in music. Give it our music chunk. This -1 is the number of loops. -1 means loop forever. So you get 1 track while you're playing this game, and it plays forever until you're very sick of it. And then this 500 is the number of milliseconds for the fade-in. So it just gives you a nice introduction over the half second before you have to listen to the repetitive music. And that's all I've got for this. Got some cool links that you guys should check out here. I'm not going to talk about them, though. You can just read them. And any sort of questions, comments, we can demonstrate the game, kind of. Like I said, it doesn't work on OS X. I couldn't get it installed. But I have a virtual machine that runs the game very sluggishly. So we can look at that as well. But I'll take questions first.
Does SDL have a 3D package?
No, SDL is only for 2-dimensional stuff. There's nothing 3D with it. It's all 2D stuff. Unless you want to get crazy and do something like Star Fox and render the polygons yourself and translate them to 2D. But
Why you would ever want to do game development in Perl to begin with.
well, like I said, I usually don't use Perl to do games with SDL, but it seemed a little silly to come present to Phoenix PM about writing games in C.
The answer to that is because you can.
Yeah, here we'll show you what you can make with. Oh goodness.
Does SDLX handle things like game states?
That's all on your own to do. Like if you wanted to, a lot of times when I'm doing it in,
Title screen to the game.
yeah. So when I do them in C, I implement that myself. But there's nothing like SDLX in C. You just have the base SDL stuff. I didn't see.
Experience with SDL too. It's just working with it directly.
Yeah, I didn't see anything about having like individual like a title screen or anything. I didn't really look though because Breakout. Well, this version of Breakout doesn't have anything but the game screen. And my EM doesn't want to play nice with the resolution here. Here we can probably kind of see. You guys can listen to the sweet music and watch me fail at Breakout real quick. So here you see just the game in action. Pretty fun. You guys can play it if you want. But yeah, that's all there is. And then yeah, that's the SCL quit thing in action. So I click that X and it quits the game.
How many exchange buffers is it using? Is it using the three buffers?
I think it does double buffering just by default. I'm not sure that I've ever made a game that would have benefited from triple buffering, but most of my games look about the same as this one.
It was pretty smooth for me. Look good.
Yeah, I'm actually surprised. Up until just now, it's been really, really choppy on the virtual machine. So, yeah, if you can run it actually on, the bare metal, it runs completely smoothly. If you get the update going a little too fast, there's some choppiness, but I think it's more persistence of vision than a problem with buffering or double buffering versus triple. That update call that you saw very early on. Let's see. Where was that? Here. This, well, I've turned it off. This update is what flips the buffers. I think it's also aliases flip if, you're more in the mindset of flipping buffers. But SDL gives you double buffering for sure by default. Basically, you don't want to draw to the screen in real time because if you're in the middle of drawing and the screen refreshes, it'll look like garbage. So what you do is you draw to a video buffer, and then when you're done drawing to that buffer, you flip between the one that's displayed and that one, and then you draw the next frame to that, and that's double buffering. With triple buffering, you have 3, and for a game like this, I'm not sure what the benefit would be to having the third buffer. If you're doing like motion blurring and stuff where you want to actually remember what was in that frame, then it can be beneficial. But for this, yeah, double buffering's fine. And yeah, like I said, all the stuff's on GitHub, so if you want to look at the source there, we didn't go over every last bit of it. The collision handling, for example, is really boring with rectangles, so we left that out. Some cool stuff that you should check out, these last 3. Okay, so Ludum. Yes, Ludum Dare it's a game jam. It takes place over a weekend. The next one's in December. I think it says that up there. What it is there's a team event and an individual event. You either get with a team and try and make a game from scratch in 72 hours, or as an individual, you do 48 hours. They announce the theme at the beginning of the contest, and you have 48 hours to make this game from scratch. Like you do the art assets, the sound, all of it during this 48 hours. It's a boatload of fun. I've done it twice now. The last one just ended maybe a month ago, and the next one's in December, and I'm pretty excited for it to happen, even though it's so far away. I make really crappy games, and they're, nobody really cares about them, but afterwards you all share the games and the source for them, so everyone can kind of learn from it. And yeah, they vote on them. Somebody wins. There's no prizes. It's great. They're actually, right now, they're doing their October challenge is to just sell a game and make $1. So it's a really cool community about promoting game development. And yes, you do get to keep the $1, but that's the only prize. Yeah. Ludum Dare is actually Latin for to give a game. So that's the thing there. Some people are fancy and they call it Ludum Dare, but I don't have a mustache or anything, so I just say Ludum Dare. It's international.
So does it happen on the internet or?
Yeah, some people actually meet up in real life and do it. I just sit at my house and don't talk to my wife for 48 hours. But some people, yeah, do meetups and stuff. Yeah, and then the other ones, the CPAN pull request challenge is something that Neil Bowers has been doing. I'm sure you guys are familiar with him. His name, well, you don't do enough Perl then. He's a big in the Perl CPAN community. He set up this pull request challenge. Basically, every month you get assigned some Perl module that has some issues, and your job for the month is to fix something with it. Send a pull request on GitHub, and there's no prizes again. I like contests without prizes.
Getting intimidated by the list of Perl modules.
Well, you only get assigned one. I haven't even looked at what my October one was. No, he picks one for you. That's what's great about it. And sometimes you get like Win32 OLE, and you're like, come on. But he'll reassign you one that's better if you don't like the one you got. But a lot of times you can find something like it's got pod errors or something. You can do something really trivial. He just wants to get people involved with contributing to these CPAN modules. Because it's easy to put something on GitHub. It's a lot harder to get people to actually help you make it. And then DigitalOcean just started today running Hacktoberfest. This one there's a prize though, so listen up for this one. The idea is you are supposed to make 4 pull requests to whatever GitHub repositories. Doesn't have to be Perl even. Just find 4 things you can fix on GitHub. If you do 4 before October's over, they'll send you a t-shirt. So I need to get myself involved with that. Neil Bowers actually told us all about that when he's like, hey, you're going to get one of these for the pull request challenge, so you might as well do 3 more and get a t-shirt. So yeah, any more questions about this stuff or the presentation?
Have you ever heard of like a Perl emulator in JavaScript? Because it sounds a little bit like SVG and like event handlers and trying to make a game in a browser.
I've not heard of something translating Perl to JavaScript, but there is something that ostensibly works with SDL. I've never gotten it to work, called Mscripton, I want to say, that it's a C compiler, but it compiles to ASM.js instead of machine language. And in theory, it will let you play your C games in a browser. But I've never gotten it to work. It's not very old. It's it's a very not friendly to use at this stage. But that's one of the things with the Ludum Dare is a lot of people will only play games in their browsers. They don't want to download random executables, and just run them. That's what I do. I don't care about stuff. It's on my Windows install, so what am I going to lose? But so like a lot of people advocate just making browser games, and people make them in like Flash or something, which is even worse than random executables. Or they'll use Unity as really popular for that, but Unity Web Player is very broken as well.
What do you typically use for Ludum Dare?
I use C++. Well, C with classes is what.
SDL?
With SDL, yeah. Well, I actually use SDL too, but there weren't Perl bindings for it. But it's more or less the same.
Quarter, man, for 48 hours?
Yeah, I like to do it up. Yeah. It works out so far. I mean, I have like a little mini framework. You're allowed to use like what they call base code. That's as long as it's publicly available. So you can see my C++ base code that actually handles the changing screens, title screens and stuff too. Yeah, I can send you a link to that if you remind me. Anything else? All right, thanks. Hope you guys enjoyed it.